We're practically living in an ocean of words. Just think about it. Annual reports, news, social media, customer reviews. We generate more text in a single day than our ancestors did in their entire lives. For decades, the big dream has been to build a machine that can read all of it, understand it, and tell us its secrets. And for a while, it really seemed like we'd cracked it. But what if there's a ghost in that machine? A hidden flaw that's twisting the very reality we're trying to measure?
All right, let's get into it. Today, we are going on a deep dive into the world of computer-aided text analysis. We're going to start with its incredible promise. Then we'll uncover a ghost in the code, hunt down where these errors come from, and reveal the absolutely shocking price of that imprecision. Then, the good part, we'll see how to fix it, and we'll end with a multi-billion-dollar question.
So, first up, the all-seeing machine. It's really important to get why everyone, and I mean everyone, from university researchers to Fortune 500 companies, got so incredibly excited about this idea of a machine that could read. This wasn't just a small improvement, it honestly felt like a giant leap for how we understand the world. At its core, the problem is just scale. There is way too much information for any single person or even a huge team of people to possibly process. I mean, imagine trying to figure out what customers really think by reading every single product review on the internet. It's impossible, right? It's a total avalanche of text. This is the big question that led to this revolutionary new tool. How do you find the real signal in all of that noise? How can you possibly measure something as fuzzy as company culture or brand sentiment from millions and millions of words, and do it consistently across thousands of companies? Well, the answer was computer-aided text analysis, or CATA. The best way to think about it is like a superpowered librarian who's also an accountant. It can read millions of documents in seconds, but instead of just sorting them, it counts specific words to turn these abstract ideas, like innovation, into a hard number that you can actually track and compare. And when you compare it to old-school methods like surveys, CATA looked like it had actual superpowers. Instead of asking a CEO in a survey if their company is innovative, it could just analyze the actual words they use in shareholder letters. You could scale it up to analyze thousands of companies, not just a handful. And it gets around the bias of people just telling you what they think you want to hear. With massive sample sizes, the conclusion should have been rock solid. It really looked like the perfect tool. But then researchers started noticing some strange things. These little inconsistencies. The big promise of perfect objective measurement started to crack. Results from one study wouldn't quite line up with another, and it became pretty clear there was a ghost lurking in the code, quietly messing with the results. This quote from the source paper just nails the problem. We got so focused on the numbers the computer was spitting out that we forgot to ask a really critical question. Just because the computer measures something, does that number actually reflect reality? Or is there something important, some kind of error, that isn't being measured at all? And right here, this is the crucial turning point. What if this machine, in its mission to be perfectly logical and unbiased, is making invisible mistakes? Not the kind that crash the program, but these subtle misinterpretations that over time add up to create a massively distorted picture of the world. Okay, so if these hidden errors are out there, where are they even coming from? Well, the researchers behind this work basically went on a ghost hunt, and they found three main culprits, three sources of digital distortion that we really need to get our heads around. The first one is called transient error, and the idea here is that texts are not created in a vacuum. A CEO writing to shareholders during a boom economy is probably going to use more optimistic language than one writing during a recession, right? Even if the company's core strategy is exactly the same. The author's mood, what's in the news that day, all these temporary things create noise in the data. Now, this second one is a huge one, specific factor error. And the real irony here is that this error doesn't come from the machine at all. It comes from the humans who build the word lists, the dictionaries that the computer uses to count. If your dictionary for innovation is missing some keywords or it has ambiguous words, the computer's final count is going to be wrong from the get-go. This slide just shows the problem perfectly. The dictionary tells the computer, hey, every time you see the word new, count it as innovation. But a human instantly sees the context, right? New product? Yep, that's innovation. New York or new regulations? Nope, not at all. The machine just doesn't have that common sense, and it makes these kinds of mistakes over and over and over. And the third culprit is algorithm error. This one is just bizarre. I mean, imagine typing 2 plus 2 into two different calculators, and one says 4, and the other says 4.01. That is basically what can happen here. Because of tiny little differences in how they're programmed, like how they handle punctuation or plural words, two different software programs can read the exact same document with the exact same dictionary and still give you different results.
So, let's just recap. Here are the three ghosts we've been hunting. Transient error, which is noise from timing and context, specific factor error, which comes from a flawed human-made dictionary, and algorithm error, where the software itself is just inconsistent. And for years, these errors were basically ignored.
Now, I want to be really clear. These errors are not just tiny academic footnotes. They have a real and often massive impact on the conclusions we draw. The researchers actually quantified this impact, and the numbers they found are, well, they're genuinely staggering. Let's see what happens when you actually measure the error itself.
In one analysis that was trying to measure a company's entrepreneurial orientation, how bold and innovative it is, the researchers found that 57% of the final score was pure measurement error. Let that just sink in for a second. The final number, the data point that people would use to make huge decisions, was more than half random noise. The signal was literally drowned out by the error from a bad dictionary. It's like trying to weigh yourself on a scale that randomly jumps up and down by 100 pounds. The number it gives you is completely useless. And you know what? It gets even worse. For another common measure, something called organizational ambidexterity, which is a company's ability to explore new ideas while also exploiting its old ones. The error was a shocking 81%. This is just profound. It means that 4/5 of what was being measured had nothing to do with what the company was actually doing. It was a ghost, an artifact created entirely by the flawed tool itself. Any conclusion you'd make based on this data would be fundamentally deeply wrong. Now, these errors don't just create random noise. They can actually hide the truth. When the researchers corrected for these errors in a study on family businesses, they found that the strength of a key relationship had been underestimated by 800%. So what this really means is that a business relationship that looked kind of minor, maybe even insignificant, through the fuzzy lens of the flawed data was, in reality, incredibly powerful and important. The noise was so loud it was hiding a critical insight that was sitting there in plain sight the whole time. Okay, after all of that doom and gloom, here is the genuinely good news. These ghosts can be exorcised. These problems are entirely fixable. The researchers didn't just point out all the flaws, they created a clear, practical roadmap for how to clean up the data and recalibrate our tools. And what's so fascinating about the solution is that it isn't to build a more powerful computer. It's to bring human intelligence back into the process. You start by having a person read a sample of the text. Then you compare what the human thought to what the machine found. And you just go back and forth. You take out words the computer gets wrong, you add in words it missed, and you replace those ambiguous words like new with specific phrases like new product. You are essentially teaching the machine about context.
And the payoff, as this chart just shows so clearly, is staggering. On the left, you see the original measure's reliability score was 0.09. That is basically random garbage. But after they refined it, on the right, it skyrockets to a highly accurate 0.87. They fixed the ghost in the code simply by combining human expertise with machine speed.
And now we get to the bottom line. This is not just some abstract statistical exercise for academics. Correcting these seemingly tiny data errors can fundamentally change our entire understanding of the business world, with consequences that are measured in billions of dollars. So let's take a classic, high-stakes question. Does being more entrepreneurial, more innovative, more risk-taking, does that actually make a company more valuable to its shareholders? The original error-filled CATA data was used to find out. The original, uncorrected data showed a positive link, but a pretty modest one, a statistical correlation of 0.24. It basically suggested that, yeah, being entrepreneurial helps a little, but it's not a game changer. But then the researchers applied their corrections, accounting for all those hidden errors, and the true relationship was revealed to be much, much stronger at 0.34. Now, a jump from 0.24 to 0.34 might not sound like a huge deal. It's just a tiny little decimal point change, right? But in the world of finance and corporate strategy, these small statistical shifts can represent enormous sums of real money. That's $2.4 billion.
That's the practical, real-world difference that small error made for a typical large company.
Let's just be really clear about what this means. The noise, the ghost in the machine, was hiding $2.4 billion in shareholder value. The original, flawed data was telling executives and investors that an entrepreneurial strategy had a modest payoff, when in reality, its true value was billions of dollars higher. The error wasn't just wrong, it was dangerously misleading.
And so, this is where we end up. We've seen how these invisible errors in something as basic as counting words can completely warp our perception of reality. And it really makes you wonder, right? If just one statistical ghost can hide a $2.4 billion truth in a single study, what other crucial insights, what other hidden realities are just lurking beneath the surface of the data we trust every single day?